Hello, I am Sunita. Welcome to my class. Here I am going to discuss one of the important topic of TET, that is metals and non-metals. Metals, a solid material which is typically hard, shiny, malleable, fusible and ductile with good electrical and thermal conductivity. For example, iron, gold, silver, aluminium, alloys such as steel. Metal is nothing but any solid material which it will show the properties of metals. They like hard, shiny, malleable, fusible, ductile, and also good electrical and thermal conductivity. We will call it as a metal. For example, aluminium, iron, calcium, sodium, potassium, magnesium, gold, platinum. Non-metals, a chemical element that lacks the characteristic of a metal. That element, it will not show the characteristic of a metal. That one we will call it as a non-metal. Non-metal or the element that do not conduct heat and electricity. It will not conduct even heat and also electricity. Are not shiny. They are not shiny. They have dull appearance. They are neither malleable or nor ductile. They will be not malleable nor ductile. For example of non-metals, carbon, sulfur, phosphorus, silicon, hydrogen, oxygen, etc. Here some of the few example of a non-metals. Physical properties of metal. Metals are hard and have a high tensile strength. Hard is nothing but metals are very hard. You are not able to easily break the metal substance. Therefore, that one we will call it as a hard. However, almost all the metals are very hard. Some of the few examples of the metals which they are soft in materials. Here sodium, lithium, gallium, cesium, potassium. These are the very important metals which are soft in material. Maybe this questions they may ask in exams, they may ask in multiple choice question. Which of the metals, even though they are hard, they will exist as a soft material? Maybe then you have to remember these examples. Because of hard property of a metal, the metal it will exist a high tensile strength. Tensile strength is the maximum amount of stretching and pulling of a metal. It is the maximum amount of stretching and pulling of a metal. Then how much time, otherwise how much time permanently it will maintain the damage, that we will call it as a tensile strength. Essentially, tensile strength is the measure how much tension the metal can resist. How much tension, otherwise how much long the metal that they can resist. That one we will call it as a tensile strength. Always remember, tensile strength is nothing but the stretching and pulling of a metal. If you stretch a metal, then stretching or pulling, how much time it can resist the tension, that one we will call it as a tensile strength of a metal. Next one, solid metals are solid at room temperature. Almost all the metals, they will be solid at room temperature. Then sonorous. Sonorous, when you beat the metal with anything, other hammer, then it will produce a ringing sound. That sound we will call it as a sonorous. Almost all the metals, they will produce the ringing sound. Therefore, the metals are sonorous. Luster. Luster is nothing but almost all the metals, they will be shining. That property we will call it as a lustrous. Lustrous is nothing but shining of the metal. Next one, metals are good conductor of heat and electricity. Consider this example. Here this pan is made up of a metal. When you heat this pan, then this pan it will get heated up. Through this pan you can, otherwise with the help of this pan you can cook the food. Therefore, almost all the metals are good conductor of heat. Then here take any one example of a metal. Connect at two ends of the metal with the help of a wire to a bulb. When you switch on the electricity, you can observe the bulb, it will blow. This it will indicate almost all the metals, they will conduct electricity. Normally, in the electrical cables are made up of a copper wire. Copper wire is one of the best example of a metal. Therefore, copper Through it, it will conduct heat and electricity. Next property, malleable, can be beaten into a thin sheet. Here you can consider any metal. If you can convert that metal into in the form of a thin sheet, that property we will call it as a malleable. It can be hammered or rolled into a flat sheet or the other shape. If you using the hammer, if you go on beating the metal, then you can convert it in the form of a thin sheet. That property we will call it as a malleable. Ductile, can be drawn into thin wires. You can see the wires here, copper wires, so many copper wires you have. Then can be ductile means can be pulled out into a long wires. These are the example of a copper wire. Then if you pull the metal, then you can convert copper into a copper wires. That property we will call it as a ductile. The next one, they have high melting and boiling point. Except calcium and gallium, they have low melting point and boiling point. Almost all the metals, they have high melting and boiling point. Dense, except alkali metals. You know, the metals are very hard, therefore in the metals all the particles, they will be very close to each other, very packed, they are arranged very packedly. There is no gap between the particles, therefore they are dense. Except alkali metals, they are not dense. Osmium, higher density, and lithium. Osmium is the example of a higher density, then lithium is the least density metal. Then lustrous, already I told, all the metals, they are having shining. That shiny nature we will call it as a lustrous. Then silver gray in color, almost all the metals, they are silver gray in color except gold and copper. These are the some physical properties of metals. These properties are very important. These properties they will ask in exams. Next one, non-metal. Non-metals are those elements which do not exhibit the properties of a metals. They will not exhibit the properties of a metal. Physical properties of non-metals. First one, occur at solid, liquid and gaseous state at room temperature. Non-metals, they will be exist as a solid, liquid, gases at room temperature. They are brittle. Non-metals are brittle. Third one, non-malleable. And fourth one, non-ductile. You can't convert non-metals. If you beat non-metals, it will not convert into a thin sheet and wire. Therefore, it is a non-malleable and non-ductile. And non-sonorous, fifth one, non-sonorous. If you beat non-metal, it will not produce any ringing sound. Therefore, it is non-sonorous. Sixth one, bad conductor of heat and electricity. Almost all the non-metals they are bad conductor of heat and electricity. Through it will not pass even heat also and electricity also. These are the few physical properties of non-metals. Exception in physical properties of metals and non-metals. This one is very important. Only these, based on these topic only, they will ask multiple choice question. Exception is very important. Remember all the points properly. First one, alkali metals like sodium, potassium, lithium can be cut using a knife. You know, almost all the metals, they are very hard. You are not able to cut with a knife. But exception cases, sodium, potassium, lithium, you can cut with the help of a knife. That is the first exception. Second one, mercury is a liquid metal. You know, almost all the metals, they will be solid. Only the mercury, it will exist in the liquid state. Third one, lead and mercury are poor conductor of heat. Almost all the metals, they are good conductor of heat and electricity, but only lead and mercury, only these two, they are poor conductor of heat. Fourth one, mercury expands significantly for the slightest change in temperature. You know, mercury we will use in the thermometer. Thermometer is filled with mercury. If you are having fever, then if your body temperature increases, then in the thermometer the level of mercury level, it will rises. it will show the significant expand of mercury. Therefore, if slightly change in the temperature of your body, the mercury level in the thermometer, it will rise. Therefore, the mercury, it will get expands when there is little slight in change in temperature also. Then fifth one, gallium and cesium have a very low melting point. Almost all the metals, they have a very high boiling point and melting point, but here exception is gallium and cesium have very low melting point. Iodine is non-metal, but it has a luster. Almost all the non-metals, they will not show any luster property. Luster is nothing but shining property. Almost all non-metals, they will not shine. Only the iodine, it will show the shining property. Therefore, it will follow a luster. Then seventh one, graphite conduct electricity. Even graphite is a non-metal. Almost all the non-metals, they will not conduct electricity. Even though it is a non-metal, graphite, it will conduct electricity. The ninth one, diamond conducts heat, has a very high melting point. Diamonds, through it will transfer the heat, and also it has very high melting point. Then these are the some exceptions in physical properties of metals and non-metals. Remember it properly. Chemical properties. Chemical properties of metal. Alkali metals like lithium, sodium, potassium, etc. react vigorously with water and oxygen present in air. Then sodium is very reactive metal. It is a highly reactive metal. It tends to react with oxygen to form sodium oxide. Listen here. Sodium react with oxygen in the air, then you will get sodium oxide. This sodium oxide is an unstable compound and soon react with hydrogen to form sodium hydroxide. And an acidic oxide react with water and produce acid. Then here lithium also react with oxygen. You will get lithium oxide. Then in the same way, how alkali metals lithium, sodium, potassium react with water. Metals react with water. You will get metal hydroxide plus hydrogen gas with the liberation of hydrogen gas. Here sodium react with water. You will get sodium hydroxide. Then hydrogen. In the same way, lithium react with water, you will get a lithium hydroxide and hydrogen gas. Then potassium react with water, you will get potassium hydroxide, respective oxide you will get with the liberation of hydrogen gas. See this picture, how sodium, lithium, potassium, how vigorously it will react with oxygen present in the air. This reaction is very explosive reaction. It will occur within a fraction of a second. Then it will cause explosion. Here in the same way, sodium, lithium, potassium react with water. This reaction also very vigorous, and you can see the change in color of the solution also here. Magnesium react with hot water. Reaction of magnesium with hot water. Magnesium does not react with cold water. It reacts with hot water to form magnesium hydroxide and hydrogen. Almost all the metals react with water. They will get their respective hydroxide. Here also magnesium in hot water react with hot water. You will get magnesium hydroxide with the liberation of hydrogen gas. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. You can observe here, when magnesium is added to water, then this reaction is also explosive. Then floating of this solution, it will happen due to the bubbles of hydrogen gas sticking its surface. Next, chemical properties of metals. Aluminium, iron, zinc react with steam. This point also you have to remember. Aluminium, iron, zinc, they will not react with cold and hot water. They will react with only steam. Metals like aluminium, iron, zinc do not react with either cold and hot water, but they react with steam to form the metal oxides and hydrogen. They will form their respective metal oxides and with the liberation of hydrogen gas. Zinc react with water. Then you will get here zinc oxide with the liberation of hydrogen gas. The next one, aluminium react with water. You will get aluminium oxide, then with the liberation of hydrogen gas. Then here iron react with water, you will get iron oxide with the liberation of hydrogen gas. This is also very important chemical reactions of metals. Reaction of metals with oxygen. Metal react with oxygen, you will get a metal oxide. Sodium, potassium are kept immersed in kerosene oil as they react vigorously with air and catch fire. Sodium and potassium, they will be highly reactive with air, therefore we have to store in kerosene. Kerosene, it will cut off the contact between sodium and potassium with air. Potassium react with oxygen, then you will get potassium oxide. This is a vigorous reaction. The next one, magnesium, aluminum, zinc, lead react slowly with air and form a protective layer that prevent corrosion. Corrosion, next I will discuss in detail. Magnesium react with oxygen, you will get magnesium oxide. Take magnesium ribbon, burns with oxygen, then you will get magnesium oxide. Magnesium burns with white dazzling light, it will appear. Then aluminium react with oxygen, you will get aluminium oxide. Silver, platinum, gold do not burn and react with air. Silver, platinum, gold, it will not burn or react with air. Basic oxides of metal. Some metallic oxides get dissolved in water, form alkali. Their aqueous solution turn lead litmus paper to blue. Sodium oxide react with water, you will get sodium hydroxide. Potassium oxide react with water, you will get potassium hydroxide. Here this aqueous solution, these two aqueous solution turns red litmus paper to blue. Amphoteric oxides. Amphoteric oxides are the metal oxide which react with both acid as well as a base to form a salt and water. Amphoteric oxide are nothing but metal oxide react with both acid and base. It will give a salt and water. For example, amphoteric oxides are aluminium oxide, zinc oxide, lead oxide, tin oxide. Aluminium oxide react with hydrochloric acid. You will get aluminium chloride plus water. Aluminium chloride is salt. Aluminium oxide same react with base sodium hydroxide. You will get sodium aluminate aqueous. This is salt and water. Zinc oxide react with HCl. You will get zinc chloride plus water. Zinc oxide react with sodium hydroxide. You will get sodium zincate plus water. Therefore, all amphoteric oxide react with acid or base to give its respective salt and water. Reaction of metals with water or steam. Some metal react with water, some metal react with steam. Metal plus water, you will get metal hydroxide or metal oxide plus with the liberation of hydrogen gas. Sodium react with water. In cold condition, you will get sodium hydroxide plus H2 plus heat, it will be liberated in this reaction. Calcium react with water in cooled condition, then you will get calcium hydroxide plus H2. Magnesium react with water in hot condition, hot water, then you will get magnesium hydroxide plus H2. Aluminium react with steam, then you will get aluminium oxide plus H2. Zinc react with water in the form of a steam, then you will get zinc oxide plus H2 gas. Iron react with water in the form of a steam, then you will get iron oxide plus H2. Here some metal they will react with water, some they will react with steam also. Reaction of metal with acid. How metals react with acid? Let us discuss here. Metal react with dilute acid, you will get salt plus hydrogen gas. Sodium react with dilute HCl, hydrochloric acid, you will get sodium chloride plus H2. Potassium react with H2SO4, dilute sulfuric acid, you will get potassium sulfate plus H2. Only Magnesium and manganese react with very dilute nitric acid to liberate hydrogen gas. Magnesium react with dilute nitric acid, you will get magnesium nitrate plus H2. Manganese react with nitric acid, then you will get manganese nitrate plus H2. Here one thing you have to remember, metals react with acid, it will give salt and hydrogen gas. Alloys are homogeneous mixtures of metals and metal with other metals or non-metal. Alloys is a homogeneous mixture of either metal or metal and non-metals. Alloy formation, it will enhance means it will increase the desirable properties of materials such as hardness, it will increase tensile strength, resistance to corrosion, everything it will get added up. Normally metals are very hard, they have high tensile strength, resistance to corrosion, everything is there. But when you mix two metals or non-metals, that one we will call it as a ion. The physical property of everything, it will get enhanced, means it will get increase. Examples of a few alloy: brass, copper and zinc, bronze, copper and tin, solder, lead and tin, amalgam, mercury and other metals. Alloy definition and examples. An alloy is a mixture of chemical elements where the primary component is a metal. Bronze, it is a mixture of copper and tin. Copper 78 to 95%, tin 5 to 22%. 18 Kelvin gold, 18 karat gold. Gold 75%, copper 12.5%, silver 12.5%. See, listen here. Alloy is nothing but a combination of different metals. Here also you can see 2, 3. Here also you can see 2, 3 combinations. Then brass, copper 60 to 90%, zinc 10 to 35%, cast iron 96 to 98%, then carbon 2 to 4%. Then sterling silver 92.5%, copper 7.5%. These are the some examples for alloy. Okay, listen here. Corrosion, gradual deterioration of materials, usually metal, by the action of moisture, air, chemicals in the surrounding environment. When you expose any metals to environment, then in the environment you are having moisture, air, chemicals, then that metal, it will react with moisture, air, chemicals, then it will form its respective oxides, then that one we will call it as a corrosion. Rusting of iron refers to the formation of rust, a mixture of iron oxide on the surface of iron objects or structure. This rust is formed from a redox reaction between oxygen and iron in an environment containing water, such as air containing high level of moisture. The rusting of iron is characterized by the formation of a layer of a red flasky substance that easily crumbles into a powder. What is meant by rusting of iron? When you expose iron materials to atmosphere, then the atmosphere, it contains air. Then in air you are having oxygen and moist. In the moist you are having water. Then this metal, it will react with oxygen and water. Then here the redox reaction, it will occurs on the surface of the metal. Then it will form a respective oxide. That process we will call it as a rusting. Then rusting, it will form a red flasky substance that easily crumbles into a powder. Because of the rusting, that metal, it will loses its strength. Then you can easily breakable or crumbles into a powder. Iron react with oxygen and water, you will get iron oxide. Corrosion of copper. Copper react with water, carbon dioxide, you will get CuCO3, CuOH twice, that is green in color. Corrosion of silver, Ag, silver react with H2S, then you will get Ag2S, plus H2. Silver you will get black color. This one you can observe silver and copper. Even in our home, normally the puja room we will use silver and copper materials or vessels we will use. If you expose copper and silver for some time, it will react with carbon dioxide, it will react with air and moisture. Then you can see a green coating of copper and black color coating on silver. That process we will call it as a corrosion. Prevention of corrosion. How you will prevent corrosion and rusting? Both are same only. Coating with paints or oils or grease. First you have to coat the vessel or ornaments or materials. You have to coat with paints or oil or grease. Application of paint, oil and grease on metal surface keep out air and moisture. If you make a coat of an grease or oil paints on the surface of the metal, then it will provide the contact between the upper surface of the metal with atmospheric air and oxygen. Then it will prevent corrosion and also rusting. Next one is alloying. Alloy is a combination of two or more metals or non-metals. Already I told alloy it will increase the strength of the metal, otherwise resistance power of the metal it will increases. Then it will prevent corrosion and rusting. For example, stainless steel. Galvanization. This is a process of coating molten zinc or iron articles. Zinc form a preventive layer and prevent corrosion. Galvanization is nothing but you have to make a coating of zinc on iron articles. With the help of a spray, you can coat zinc with iron article. That process we will call it as a galvanization. When you galvanize, then that zinc it will disconnect the contact between oxygen and water with iron. Then it will prevent corrosion. Next one, electroplating. It is a method of coating one metal with another by the use of electric current. Electroplating is nothing but already you are having iron, then you are making a coating, otherwise you are making a coating with another metal using the process of electric current. This method is not only leads protection but also enhance the metallic appearance. For example, silver plating, nickel plating. This it will enhance the strength of the metal also. Then it will enhance the appearance of the material also. Normally we will use silver plating and nickel plating. This electroplating you can see in the vehicles, motor vehicles, car, bus, everything, aeroplane, rocket, we will use electroplating only. Fifth one, sacrificial protection. Magnesium is more reactive than iron. Yes, magnesium is more reactive than iron. When it is coated on the articles made up of iron or steel, the articles is made up of iron and steel is coated with magnesium, then that magnesium it will act like a cathode, then undergo reaction. That reaction we will call it as a sacrifice instead of iron and protect the articles. Here also this magnesium it will disconnect the contact between oxygen and water present in the air. Then it will protect the metal from corrosion. These are the very good important methods you can prevent corrosion. The non-metal which is liquid at room temperature is option A mercury, option B bromine, option C carbon, option D helium. Answer is bromine. Bromine is the one of the non-metal which is a liquid at room temperature. Bromine is only one non-metal which exists as a liquid at room temperature. The number of protons in an atom of an element A is 19. Then the number of electron in its ion A plus is, when will be the atom? It will possess positive charge. The atom it will possess positive charge when it will gives one electrons to another atom. Otherwise, when it is loses one electron to another atom, then it will acquire a positive charge. Here only positive means it is giving only one electron. If it is 2 plus instead of plus, if you are having 2 plus here, then it is giving 2 electron. If here 3 plus means it will give 3 electrons like that. But here they are given only 1 plus. A plus means it will give 1 electron to another atom. Then here A is 19. If it is gives 1 electron to another atom means 19 minus 1, it will be 18. The correct answer is 18 in the neutral atom of an element. Bauxite is one of the ore of option A iron, option B aluminium, option C mercury, option D copper. Bauxite is one of the ore of aluminium. Bauxite is a commercial ore of aluminium which consists largely of hydrated aluminium oxide Al2O3 2H2O. The metal which is liquid at room temperature is option A bromine, option B mercury, option C iodine, option D potassium. The correct answer is mercury. Mercury is the only metal which exists a liquid at room temperature. Next question. The sulfide ore are converted into oxides. Sulfide ore here converted into oxide by heating strongly in presence of excess air. This process is known as option A roasting, option B smelting, option C calcination, option D refining. The correct answer is roasting. Roasting is the process of heating the sulfide ore strongly in presence of air to convert it into metal oxide is known as a roasting. In electrolytic refining, the cathode is made up of option A pure metal, option B impure metal, option C alloy, option D metallic salt. The correct answer is pure metal. In an electrolytic refining of a metal, the cathode is made up of a pure metal whereas the anode is made up of a impure metal. Maybe sometime they will ask about anode also, therefore you have to remember anode is made up of a impure metal. In the given reaction Al2O3 plus NaOH, it will give X plus H2O. What is X? They are asking the question. Aluminium oxide is amphoteric in nature, that is it react with acid as well as a base to form salt and water. What is meant by amphoteric in nature means amphoteric is nothing but it will react with acid as well as a base. Here aluminium oxide behaves as an acid. This here it will behave as acid. It react with a base sodium hydroxide. It will give rise to sodium aluminate and water. Which of the following represent the correct order of decreasing reactivity? You know, reactivity series means the metals, highly reactive metal, they will replace less reactive metal in the displacement reaction, that you know. Here they are asking the question, arrange the reactivity metals in the order of decreasing order. They are asking question. Here this is the decreasing order of the reactivity of the common metals is given below. Lithium, here the decreasing order of reactivity series. Therefore, magnesium is highly reactive compared to aluminium, zinc and iron. This is the decreasing order of reactivity of metals. An element reacts with oxygen to give a compound with a high melting point. This compound is also soluble in water. The element is likely to be first option calcium, second one is carbon, third option silicon, fourth one is iron. The correct answer is calcium. Calcium reacts with oxygen to give calcium oxide. Calcium reacts with oxygen, it will give calcium oxide which is having a high melting point and dissolved in water to form calcium hydroxide along with the release of large amount of thermal energy. Therefore, the correct answer for this question is calcium is the element react with oxygen to give a compound with a high melting point. This compound is also soluble in water. The element is calcium. Which of the following pairs will give a displacement reaction? Displacement reaction is nothing but highly reactive metal displaces a less reactive metal. Option A, sodium chloride solution and copper metal. Option B, magnesium chloride solution and aluminium metal. Option C, iron sulfate solution and silver metal. Option D, silver nitrate solution and copper metal. The correct option is silver nitrate solution and copper metal, because copper is highly reactive than silver. Therefore, it will displace silver from silver nitrate solution to form a copper nitrate. This is the equation. Silver nitrate plus copper react to give copper nitrate and silver. This copper, it will react with this nitrate, then it will displace silver because of this highly reactivity of copper. Which among the following is the most abundant metal found in the earth crust? Option A, magnesium. Option B, aluminium. Option C, oxygen. Option D, iron. Answer B, aluminium. Aluminium is the most abundant metal found in the earth crust. Most abundant means aluminium, it will exist more in the earth crust compared to remaining metals. Which among the following is the most abundant metal found in the earth crust? Option A, magnesium. Option B, aluminium. Option C, oxygen. Option D, iron. Correct answer is aluminium. Aluminium is the most abundant metal found in the earth crust. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of option A, copper, B, aluminium, C, zinc, D, bauxite. Zinc. In this method, a thin layer of zinc metal is deposited over the surface of steel or iron object. Galvanization is nothing but to protect the metal from moist air or oxygen or atmospheric gases. You have to make a coating of another metal. Here, a thin layer of zinc metal is deposited over the surface of a steel or iron object, which does not corrode and explode to damp air and prevent the coated metal from rusting. It will prevent the metal from rusting. Therefore, here we will use zinc to protect the metal iron. Which of the following alloy contains a non-metal as one of its constituents? Option A, steel. B, brass. C, amalgam. D, bronze. Answer is steel. What is mean by an alloy? Alloy is a combination of two or more metals or combination of metal and non-metals. Alloys are very strong compared to metals, because alloys is a combination of metal or metal non-metal. Then it will gives extra addition to the strength of the metal. Then here stainless steel is an alloy of iron, a metal, and a carbon is a non-metal. Here they are given the example of an alloy. It is a combination of metal and non-metal. Here stainless steel is an alloy of iron. Stainless steel is the alloy. It is a combination of iron, a metal, and a carbon, non-metal. An element X is soft and can be cut with the help of a knife. It is very reactive to air and cannot be kept open in the air. It reacts vigorously with water. Identify the element from the following. First one is magnesium. Option B, sodium. Option C, potassium. Option D, calcium. The element is sodium. Sodium is a metal which is soft enough to be cut with a knife. You know, almost all the non-metals are highly solid and also they are hard. You are not able to cut very easily, but sodium is the exception case. Only one metal which is exist as a soft you can cut with the help of a knife. It is also reactive, that react vigorously with air and moisture and catches fire when kept in open. If you expose sodium to a atmosphere, then immediately it will catch fire. Why it will immediately catch fire means it will react with air or moisture. It is present in the atmosphere. So to be prevented it from coming in contact with oxygen and moisture, it is kept in kerosene. Because of this property of sodium, it will catch immediately fire when you expose to air. In the air you are having oxygen and moisture, it will react immediately. Therefore we have to store sodium in kerosene. Thanks for listening my class. Send me your valuable feedback. Here I discussed the topics metal and non-metals. Then I solved some of the few MCQ questions based on metals and non-metals. Please follow all my classes. These classes are very important. You can clear your TET exams very easily if you follow all my classes.